Okay, I'm here showing you this slide again, which gives an example of code division multiple access. And in this slide, which is taken from Stallings' Datacom book, gives a great little example of what I'm going to call 7 different users. Stalling calls them 7 different channels, users 0 through 6. And what it shows is each of these users sending 1 bit. Okay? Each user sends 1 bit. Over the air we get 7 different waveforms which all superimpose and add up. There's the summation symbol. And they superimpose to form this output, the composite signal. Okay? This is the signal that goes through the air, and this is the signal that the receiver receives. Okay? So what this is showing is it's showing that the receiver is taking user number 0's code, or channel 0's spreading code, and multiplying it by the received signal. And it does this at each point in time here, for each of these received what I call chips. Okay, and so you can see here is the result of that multiplication over here on the right, and I'll just take you through it. We have the channel 0 code, and we're going to interpret this as +1, +1, +1, -1, -1, +1, and -1. And we're going to multiply by the corresponding composite signal. Now the composite signal has values 5, 1, 1, -3, 1, -3, and -3. And that's because the 0 value is along this horizontal here. Okay? And so we'll see how this works. We're going to take +1 and multiply it by 5, and we're going to get 5. +1 multiplied by 1 gives a 1. +1 times 1 is a 1. Now I have -1 times -3 gives a +3. -1 times +1 gives a -1. +1 times -3 gives -3. Finally, -1 times -3 gives +3. Okay, so that's the multiplication, and you can implement that in a spreadsheet quite easily. Okay, next, what does the receiver do? The receiver gets this signal now, and what the receiver does is he just adds all of those values. He's going to add 5 + 1 + 1 + 3 -1 -3 +3. And that let's see, that gives us 5, 6, 7, 8, 9, 10. -1 is a 9, and then +3 -3 leaves the 9. And 9 is our output. And what we do with this is we take its sign, plus or minus, and because 9 is positive, the output from channel 0 is a +1. And you see that is exactly what channel 0 sent. Now what you can do, and in your spreadsheet you should allow for this, you should allow to plug in channel 1 code, the code from channel 2, the code from channel 3, the code from channel 4. Plug in any channel's code here and get out the correct corresponding bit that was sent by that channel. Okay? And now here's the trick. So I've shown you how the receiver works. Let me show you just a quick example of the summation of these signals to get the composite signal. Here I've got 7 different signals. These are the individual channel waveforms. These are the things that each of the users or channels sent out onto the air. And because it's a shared medium, they all superimpose. That is, they all add up. So look, I have a +1, +1, +1, +1, +1, -1, +1. So I have 1, 2, 3, 4, 5, 6 positives and 1 negative. That gives me a 5 positive. Here I have plus, minus, minus. +1, -1 gets me to 0. -1 takes me to -1, -2, back up to -1, back up to 0, to +1. So I'm just adding those values, and these are interpreted as +1 and -1. Okay? And so you can do that to get this whole waveform, adding up the columns over here. And finally, here's the trick. In this diagram, he shows you the channel waveforms. Each user, or each channel, sends out a waveform which is the bit multiplied by the channel code. First of all, the bit is taken to be either +1 or -1. So in your spreadsheet, use -1s for these zeros here. Okay? And you can see on channel 0, he shows you what channel 0's code was. And channel 0's bit was a 1. That means we're multiplying 1 times the code to get this channel waveform. In other words, what you're seeing here are not necessarily the channel waveforms, but either the channel waveform or the inverted channel waveform. Every time you see a 1 here, you're seeing the actual channel waveform. So this is the actual channel waveform for channel 0. This is a 1, so this is the actual channel, the actual spreading code for channel 2. And here's another 1 down here, so this is the actual spreading code for channel 6. Where you see zeros here, these are the inversions of the spreading codes. So the actual spreading code for channel 1 looks like this. It looks like negative, plus, 3 pluses. Oh boy, not looking too good, John. Let's do that. Let's try that again. Here's channel 1's spreading code. And it's going to be the opposite of what we see here. So it's going to be minus, plus, 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 minus, minus, plus. Minus, plus, 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 minus, minus, plus. And if I finish my diagram here, you can see it. So this is the actual channel 1 code. And it's the opposite of what you see here. Okay? And I hope that helps. That takes you through the entire calculation again, starting with the bits that the users are sending, and starting with their channel codes to coming up with the channel waveforms, which are either the channel code or the inverted channel code, summing them, coming up with the composite signal, and then at the receiver taking the composite signal and multiplying by one of the channel codes to extract that channel's bit. And 9 is greater than 0, so the output bit is a 1, which agrees with the input bit from channel 0. Okay, hope that helps. Have fun with the spreadsheets, and let me know if you have any questions.